Hello, everyone. Welcome to Module 4, Finance in Digital Transformation. My name is Dr. Rosita Abdurrahim. You can call me Dr. Rosita. As you might have guessed, I am one of the instructors from UKM, Universiti Kebangsaan Malaysia, or the National University of Malaysia. Let me recap your memory on how Module 4 comes in this course on AI in the era of digital transformation. For the past 7 or 8 weeks, you have gone through modules 1 until 3. Today, we will begin lecture on module 4, which is the last module covering finance in digital transformation. This module covers 3 topics. Mine is on blockchain, and then Dr. Hasimi will cover fintech, financial technology, and then 2 instructors from Sun Yat-sen University will be covering digital supply chain and finance. Blockchain is an undeniably ingenious invention. It is the brainchild of a person or a group of people known by the pseudonym of Satoshi Nakamoto. It was originally devised for digital currency, Bitcoin. Since Bitcoin, blockchain has evolved into something greater. There are endless potential users for the technology. But what is blockchain? There are several definitions that you can see on the slide, but for non-technical people like us, users instead of developers of the technology, the gist of what blockchain is can be clearly understood from the last definition. It says blockchain is a shared, immutable, that means cannot be changed, ledger or record that facilitate the process of recording transaction and tracking asset in a business network. These assets can be tangible like house, car, cash, or land, or intangible like intellectual property, patents, copyrights, and branding. Virtually anything of value can be tracked and traded on a blockchain network, therefore reducing risk and cutting costs for all involved. In a super simple terms, a blockchain is a computer file of storing data. When we are talking about blockchain, some might think that we are talking about Bitcoin. So before we proceed further into blockchain, I would like to clarify the misconception that blockchain and Bitcoin are the same thing. So how are they different? Recall that blockchain is an open distributed ledger or database, but again, this sounds a bit like Bitcoin, right? On this note, blockchain is the technology that underpins Bitcoin, and it was developed specifically for Bitcoin. So Bitcoin was the first example of blockchain in action, and without blockchain, there would not be Bitcoin. That's why the two names are often used interchangeably. Meanwhile, Bitcoin is a decentralized digital currency. It's a currency, like the fiat currency, the money that you are using, right? Or a peer-to-peer electronic payment system, where users can anonymously transfer Bitcoins without the interference of a third-party authority like the central bank or the government. While we are on it, note that Bitcoin is just one example of cryptocurrency. If you could check in CoinMarketCap, currently there are more than 4,000 cryptocurrencies available for trading, not just Bitcoin. So in short, the slide provides us with the main difference separating Bitcoin from blockchain. First, Bitcoin is a cryptocurrency, digital currency, while blockchain is a distributed database. Second, Bitcoin is powered by blockchain technology, but blockchain has found many users beyond Bitcoin. Third, Bitcoin promotes anonymity, while blockchain is about transparency. To be applied in certain sectors, particularly banking, blockchain has to meet strict know your customer KYC rules. Bitcoin transfers currency between users, while blockchain is the technology that can be used to transfer all sorts of things, including information or property ownership rights. So in short, although Bitcoin uses blockchain technology to trade digital currency, the blockchain is more than just Bitcoin. In this module, we will be looking at the wider application of blockchain beyond cryptocurrencies. But first, let's see how blockchain works. This diagram is quite detailed in showing how a blockchain works or how it is created. Note that blockchain is simply a record of transaction, but that transaction is just the same ones that we, businesses normally do. It begins when someone requests to have a transaction, for instance, to buy a currency, a building, or even an exotic pet. As transaction occurs, it is recorded as a block of data. Those transactions show the movement of an asset that can be tangible or intangible. The data block can record the information of your choices: who, what, when, where, how much, and even the condition, such as the temperature of a food shipment. Each block is connected to the ones before and after. So that's why it is difficult for us to change the information in the blocks. This block forms a chain of data as an asset moves from place to place or ownership changes hands. The blocks confirm the exact time and sequence transaction, and the blocks link securely together to prevent any block from being altered or a block being inserted between two existing blocks. Transactions are blocked together in an irreversible chain, a blockchain. Each additional block strengthens the verification of the previous block and hence the entire blockchain. This renders the blockchain tamper evident, delivering the key strength of immutability. This removes the possibility of tampering by a malicious actor and builds a ledger of transaction you and other network members can trust. So a blockchain is simply a chain of blocks that contain information. Blockchain contains an ever-growing list of records called blocks, which are linked using the technology or the cryptography. Yeah, when I say cryptography, it is a process which encrypts and secures data communication to prevent third parties from reading private messages. So this slide shows an example of blockchain for a transaction involving cryptocurrency. I have to ask you to please take a look at the example. We will discuss it later during our meeting in May. And at this point, you probably want to know what is really inside the block or the record in a blockchain. So you see from the slide, this is an example of transaction from Ethereum, which is one of the cryptocurrency next to popularity and also next to size after Bitcoin. A block is a container that holds a list of transactions that are to be added to the blockchain. The block allows us to manage the list of transactions efficiently by breaking them into blocks. So the content of the block, in this case, we are looking at block 5629306. Look at the header of the block. It contains the previous block hash. This provides a method to link the blocks in the blockchain, TX hash. All blockchains use hash. Hashes are long series of random settings used to track your transaction. With the use of transaction hash or a wallet address, if you are using cryptocurrency or blockchain wallet, for example, then anyone can check the detail of your transaction. You may find the transaction hash to check the status of your transfer. Please note that to pass successfully, Your transaction should receive a certain amount of confirmation. The confirmation will turn to green when it was successfully processed. You will find the sender's wallet address and the destination wallet address together with the amount and the fees of your transfer. And then there is age or time. This is the information telling about when the block was made. This helps solve the problem of double spending. Using the timestamp, you can catch if someone is trying to spend the same money twice and validate the right transaction based on which happened first. And there are also Merkle roots, especially if you're talking about mineable or cryptocurrency that can be mined like Bitcoin. Merkle root is a hash value that is generated by repeatedly hashing pairs of transaction till only one hash value is left. So in this slide, we show you the hash, right? And here, hash serve as a public address, just like when we are talking about an identity, and by using hash, this is like public address that will hide your identity. So this is how we got the anonymity from blockchain. So instead of showing people that you are sending the money to another person, then what come out in the blockchain or the block is all these hash that will not be able to identify you directly. Why is blockchain important to business? Well, the answer is on information. Business runs on information. Every single steps or action in business requires information. The price, the demand, The faster information is received and the more accurate it is, the better decision and action will be made. Blockchain is ideal for delivering that information because it provides immediate, shared, and completely transparent information stored on an immutable ledger that can be accessed only by permission network members. A blockchain network can track orders, payments, accounts, production, and much more. And because members share a single view of the truth, the same record, you can see all details of a transaction end to end, giving you greater confidence as well as new efficiencies and opportunities. Blockchain has changed how we perceive problem. It has brought tons of benefits, so that's why businesses need blockchain. Blockchain technology solves key issues like trust in a network. By changing the key parameters, trust, any organization can focus on solving the problems at hand. Global governments have also understood its importance and are keen on implementing blockchain technology. For example, recently, Dubai Smart City 2020 is a project which aims to build a smart city with new technologies, including blockchain. So what are the benefits of blockchain technology? Because I don't have enough time to describe the details in this video, I need to ask you to go through the top 5 benefits and also advantages in this slide on your own until our meeting in May. Next, let's see how blockchain can provide these benefits by understanding its properties or features. The diagram shows 6 of the blockchain main features. First is faster settlement. Because blockchain automates the whole network, it offers a faster settlement compared to traditional banking system in the case of banking. This way, a user can transfer money relatively faster, including for cross-border transaction, and that saves a lot of time in the long run. Second, increased network capacity. Blockchain is a peer-to-peer technology. It means having thousands of computers or nodes working together as a whole, and that can have greater power than a centralized service. Third, more secure. Blockchain eliminates the need for central authority, no government or central banks, No one can just simply change any characteristic of the network for their own benefit. Also, using encryption ensures another layer of security for the system. The fourth one is immutable. Every node on the network has a copy of the digital ledger. To add a transaction, every node needs to check its validity, its confirmation. If the majority thinks it is valid, then it is added to the ledger. This promotes transparency and makes it corruption proof. Shared and distributed ledger. The ledger on the network is maintained by all other users of the system. This distributes the computational power across the computers to ensure a better outcome. Last, decentralized technology. The network is decentralized, meaning it doesn't have any governing authority or a single person looking after the framework. Instead, a group of nodes maintain the network, making it decentralized. Next, you need to understand that there are various types of or variation of blockchain. When blockchain technology was introduced to the world, it was a public blockchain type with currency use case. It is really hard to understand the intent of its creator, Satoshi. But in general, it provided the concept of decentralized ledger technology or DLT. DLT solved the drawbacks of centralization, but in itself, DLT brought a lot other problems. For instance, Bitcoin used an inefficient consensus algorithm, proof of work. It required the nodes to solve mathematical calculation using energy, electric. Initially, it was not a problem, but as soon as the difficulty of solving the mathematical equation increased, even more time and energy are required. This inefficiency makes it not suitable for a system that needs to stay efficient. For example, banks deal with a lot of transactions every day. So this public blockchain type is not suitable for banks. So blockchain evolved to several types to best suit the user's need. First, in addition to public, we also have private. But let's define what public blockchain is first. Public blockchain is a permissionless. You don't need permission, which means everyone with internet access can access, join, and participate in the blockchain, such as the case for Bitcoin. The drawbacks of blockchain might include substantial computational power required, little or no privacy for transaction, and weak security. These are important considerations for enterprises' use case of blockchain. Then we have private blockchain. Similar to a public blockchain network, in that it is decentralized peer-to-peer network. The significant difference is that private blockchain has one organization that governs the network. Private blockchain is permission, which means the organization controls who is allowed to participate in the network, execute a consensus protocol, and maintain a shared ledger. Depending on the use case, this can significantly boost trust and confidence between participants. A private blockchain can run behind a corporate firewall and even be hosted on premises. So I mentioned a few times about permission blockchain. What is it? It is businesses that set up a private blockchain will generally set up a permission blockchain network. It is important to note that public blockchain networks can also be a permission. This permission places restriction on who is allowed to participate in the network and only in certain transactions. Participants need to obtain an invitation or permission to join. Next, we have consortium or multiple organization blockchain, or sometimes it is called federated blockchains. Consortium blockchain is when multiple organizations can share the responsibilities of maintaining the blockchain. This pre-selected organization determine who may submit transaction or access the data. A consortium blockchain is ideal for business when all participants need to be permissioned and have a shared responsibility for the blockchain. So a consortium blockchain is a creative approach to solving organizations' need where there is a need for both public and private blockchain features. In a consortium blockchain, some aspects of the organization are made public while others remain private. Finally, we have hybrid blockchain. Hybrid blockchain might sound like a consortium blockchain, but it is not. However, there can be some similarities between them. Clear difference include the number of organizations involved and that hybrid blockchain is regulated. Now, I hope that you have some ideas about what blockchain is, how the technology works, its properties, and how it brings changes to businesses. There are several fundamental issues that I will discuss during our meeting in May. I'll be discussing the changes blockchain bring to the third generation of internet, smart contract, and use cases of smart contract. In the next video, I will go through the sectors and enterprise that are taking advantage of blockchain technology. So that's all for now. I'll see you again in the next video. Bye.